In the winter of 1601, far from any battlefield or political intrigue, entire communities across the northern hemisphere began to face a quiet and unrelenting crisis.
Crops failed without warning. Summers arrived cold and dim. Rivers froze earlier than memory could recall.
In regions separated by oceans and cultures, the same pattern emerged: hunger, uncertainty, and a growing sense that something in the natural world had shifted beyond human control. Few could have known that the source of this disruption lay high in the Andes Mountains of present-day Peru, where a volcanic eruption unseen by most of the world had already altered the course of global history.
The volcano responsible, Huaynaputina, had shown little indication of the scale of destruction it would unleash.
Located in a remote region of southern Peru, it was not widely recognized as a major volcanic threat prior to 1600.
Unlike more prominent peaks, Huaynaputina lacked a towering cone, blending instead into the rugged Andean landscape. Yet beneath its surface, pressure had been building for years, driven by tectonic forces along the boundary of the Nazca and South American plates. In February of 1600, the region experienced a series of earthquakes.
These tremors unsettled local populations, many of whom interpreted them through the lens of spiritual or supernatural meaning. But the seismic activity was a precursor to something far more significant. On February 19, the volcano erupted with extraordinary force.
The initial explosion sent a massive column of ash and gas high into the atmosphere.
Within hours, pyroclastic flows, fast-moving currents of hot gas and volcanic material, swept down the slopes, destroying everything in their path. Nearby villages were buried under layers of ash. Agricultural land, which sustained local communities, was rendered unusable almost instantly. The eruption did not subside quickly. It continued for weeks, ejecting enormous quantities of volcanic material into the stratosphere. Fine ash particles and sulfur dioxide gas spread far beyond the immediate region. While the local devastation was severe, the broader consequences were only beginning to unfold. As the volcanic plume dispersed into the upper atmosphere, it formed a veil of aerosols that reflected sunlight away from the Earth's surface. This phenomenon, though not understood at the time, had a measurable impact on global temperatures. In the months that followed, regions across the northern hemisphere began to experience unusual climatic conditions. The summer of 1601 was markedly colder than average. In parts of Europe, crops failed due to shortened growing seasons and unexpected frosts. Historical records from countries such as Russia, Sweden, and France describe persistent cold, poor harvests, and rising food prices. In Russia, the situation escalated into one of the worst famines in the nation's history. Between 1601 and 1603, Russia experienced widespread crop failure. Grain reserves were depleted rapidly, and the government struggled to respond effectively. The resulting famine led to significant population loss and social instability. Reports from the period indicate that entire regions were affected, with people abandoning their homes in search of food. In Western Europe, the impact was less extreme but still deeply disruptive. Agricultural yields declined, and communities faced shortages that strained local economies. In some areas, increased rainfall compounded the problem, damaging crops already weakened by colder temperatures. The combination of environmental stressors created conditions that were difficult to predict and even harder to manage. Beyond Europe, evidence suggests that the climatic effects extended into Asia.
In China, records from the Ming Dynasty note unusual weather patterns, including unseasonal frost and reduced agricultural productivity.
These disruptions contributed to economic difficulties and added pressure to an already strained political system. Japan also experienced cooler temperatures and poor harvests. Historical documents describe periods of food scarcity and hardship among rural populations.
While the connection to the eruption was not recognized at the time, modern scientific analysis has linked these widespread anomalies to the atmospheric changes triggered by Huaynaputina.
In the Americas, the effects were more localized but still significant. In parts of North America, tree ring data indicates reduced growth during this period, suggesting cooler conditions. While indigenous communities had diverse and resilient agricultural practices, they were not immune to sudden climatic shifts. The global nature of these impacts underscores the scale of the eruption.
Huaynaputina is now considered one of the largest volcanic events of the past millennium.
Its eruption released an estimated 30 cubic kilometers of material, placing it among the most powerful eruptions in recorded history. At the time, however, there was no framework for understanding how a volcanic event in one part of the world could influence weather patterns across continents. The concept of global climate systems was centuries away from being developed. As a result, societies interpreted these changes through local perspectives, often attributing them to divine will, natural cycles, or unexplained misfortune. The social consequences of the eruption were profound. Food shortages led to rising prices, which disproportionately affected the poorest members of society. In some regions, this economic strain contributed to unrest and migration. Governments faced increasing pressure to provide relief, but their capacity to respond was limited by both logistical challenges and incomplete information. In Russia, the famine coincided with a period of political turmoil known as the Time of Troubles. The combination of environmental disaster and political instability created conditions that were particularly severe. While the eruption was not the sole cause of this crisis, it played a significant role in exacerbating existing vulnerabilities. In Europe, the agricultural disruptions influenced trade patterns and local economies. Regions that relied heavily on consistent harvests found themselves adapting to uncertainty. Some communities turned to alternative food sources, while others faced prolonged hardship. The long-term effects of the eruption extended beyond immediate famine and climate anomalies. The event contributed to a broader understanding, developed much later, of how volcanic activity can influence global systems. Modern climate science has identified similar patterns in other major eruptions, such as those of Tambora in 1815 and Krakatoa in 1883. Huaynaputina, however, remains distinctive due to the scale of its impact relative to its historical visibility. Unlike later eruptions that were documented in greater detail, this event occurred in a period when global communication was limited. As a result, its significance was not fully recognized until centuries later, when scientists began to analyze historical climate data alongside geological evidence. Ice core samples from polar regions have revealed elevated levels of sulfate deposits corresponding to the year 1600. These findings provide direct evidence of the eruption's atmospheric effects. Combined with tree ring data and historical records, they offer a comprehensive picture of how a single geological event can influence global conditions. The study of Huaynaputina has also contributed to modern approaches to risk assessment and disaster preparedness. By examining the links between volcanic activity and climate change, researchers have gained insights into potential future scenarios. While technology has advanced significantly, the fundamental processes that drive such events remain the same. Today, the site of the eruption is quiet, its dramatic history largely hidden within the landscape. There are no towering remnants or constant activity to signal its past. Yet the legacy of Huaynaputina endures in scientific research and historical analysis. The events of 1600 serve as a reminder of the interconnected nature of Earth's systems. A volcanic eruption in a remote region can alter atmospheric conditions on a global scale, affecting societies far removed from the source. These connections, while now better understood, continue to shape how we interpret both past and present environmental changes. The famine that followed the eruption was not a single, isolated event but part of a complex chain of consequences. Climate anomalies led to agricultural failure, which in turn influenced economic and social structures. The ripple effects extended across continents, illustrating how environmental factors can intersect